Okay, this lesson is on the sine rule, the cosine rule, and the area of a triangle. The one we're going to focus on first is another formula to calculate the area of a triangle when it's non-right angled. Okay, so let's remind ourselves of the formula we've got for the area of a triangle already. Base times perpendicular height divided by 2. So if you look at this triangle here, A, B, C, if we're to work out that area of that triangle, in the past we've had the base, we've had the perpendicular height, we would times those two numbers together, and then we would chop it in half, or divide it by 2. What we're now going to do is derive a different formula, which will work when we haven't got this perpendicular height. Now, in mathematics, it's common for us to use the side opposite the angle to be represented by a lowercase letter. So the angles tend to be capitals, A, B, C. The side that's opposite that angle is a lowercase letter. So angle A is here, so we will label this as little a. Angle C is here, so we label this as little c. And angle B is here, so we label this as little b. These letters are going to be very important when we start looking at the sine and cosine rule as well, because that's how we're going to label triangles using that technique. So, if I want to use this formula, what I've really got to calculate, if I call this here, this point in here, letter D, what I really want is to calculate the length of BD. Why? Because I've got that length already. That's letter B. I've got nothing representing the perpendicular height of this triangle. Now this is why it's very important to access this lesson on sine, cosine rule and area of triangles, that you go back and look at the key stage 4 lesson on trigonometry. It's absolutely critical. Okay, trigonometry with right angled triangles. So what I'm going to do is I'm going to find this length here, okay, or represent it with letters. So I'm going to calculate the length BD. So what have we got? We've got a right angled triangle inside here, and we've got a right angled triangle inside here. What I'm going to do is I'm just going to use this right angled triangle. I could have used that one, I'm just going to use this one. And I'm going to look at this angle inside here, okay, angle C. Now, from our work on trigonometry, we would label this right angled triangle. This would be the opposite side. This here would be the adjacent side. And this here would be the hypotenuse side. Because I want to calculate this side, okay, and I have got this side, remember you haven't got this full length to here. You've got the length all the way across is letter B, but you haven't got that length. So the ratio I'm going to use is the sine ratio. So the sine of angle C is equal to the opposite side over the hypotenuse side. Which one am I trying to calculate? I'm trying to calculate the length of BD, so that is the opposite side. I know the hypotenuse side is letter A, so I replace that now by length BD. The hypotenuse side is letter A, so BD, remember how we get rid of divide by A, times by A, so BD is A times sine C. I have now got that length represented by A sine C. Now I can use this formula. The base is B, so B, times the perpendicular height, which was the length of BD. The length of BD is A sine C. And don't forget, we've got to divide that by 2, so I'm taking half of it. So, half of that answer. What you've got there is you've got a formula to calculate the area of a triangle when you haven't actually, physically, need that length. You don't need the perpendicular height because the formula includes it in it. So, tidy that up a little bit, just tidy the letters, put it in different formats. We have there a formula to calculate the area of a triangle when you haven't got the perpendicular height. Half AB sine C. Not only could it be half AB sine C, if we did it from this triangle, or we switched the letters round, you would have different formulas, but just using different letters. We could have half BC sine A, or we could also have half AC sine B, just depending on which triangle we used, or the rotation of the letters. They would all work and they would all calculate the area of that triangle.